Hello everyone. Once again, thank you so much for joining us. So in today's session, we'll be trying to understanding how like the Docker like introductions. We have already discussed yesterday also and also understood some of the components, major components. But today I'll once again walk you through from little bit in the high level. Once we complete the introduction, maybe we will start with the module 2. That will be about your basically creation of the image. Let me take you there. Yeah, so we will be starting the module 2, that is basically image creations, management, and registry. Let's say we will try to create the image from scratch. Then we will see how we can manage the image. Also, we will tag them so that we can post to the respective registry. Say, for example, we can post to the Docker Hub. We can post to the Azure Container Registry as well. So, how we can manage the image also, we will see everything in the real time. Okay, so let's get started. So as I mentioned, we are be discussing once again on the high level about the introduction to Docker. So what is Docker? Docker is an open source software platform that simplifies the process of building, shipping, and running application by using containers. So it is very simple. So when I say the Docker, so we need to understand three terms here. One is a building, shipping, and the running. Building mean basically you are building as in you're building your applications. Then we are going to deploy with the help of shipping. We are going to deploy to respective environment. It could be your particular dev environment or any environment in particular cloud, right? Then if we can run that one, running by running what, using the we can run the application using containers. Now container, as we have already discussed yesterday, is nothing but it is a lightweight isolated environment where it contains all your application core, system libraries, or maybe like configuration files, everything that contains. Say for example, we have applications. Say in our case, let me take you one more, maybe here, GitHub. Okay, just for example, on the high level, say for example, we have these .NET based applications. This is basically code based right now. So what we can do here is, say for example, this is applications. Now this contains all your application related code, right? So this is a code now. So how can we make this one make use of the containers, right? Or maybe containerize these applications. So in order to containerize the applications, first we need to have the Docker file, right? So Docker file is nothing but it contains the setup instruction. Now setup instruction that means, say for example, manual. Just let's talk about the manual way or traditional way. If you want to maybe deploy these web app applications, sorry, web app for .NET application, if you want to deploy or somewhere, let's say manually, if you had to do, there will be certain prerequisites or certain commands that you need to execute, right? You cannot simply deploy the application unless you have your dependency ready. That means in order to make sure your application working fine, you need to have this certain dependency ready already or installed, right? Same way, with the help of Docker file also, we can define the setup instruction. Setup instruction is nothing but setup prerequisites. You can define that, right? So that you can basically based on the commands that you define as an argument in your or in your Docker file, it will get executed. Then your application will be able to basically create as a containerized image. Once the application or this particular application is containerized, what we can do is that is when we know that is called as Docker image. That means, or I can call as a containerized. We have containerized the particular ASP.NET application, as simple, right? So once we containerize the image, next what we can do, we need to deploy somewhere, right? So as I told you, with while writing this thing also, there's a container, because something called as a container. The application where it will be deployed. The application will be deployed in your the application will be deployed in your container basically, right? By using the container. Now container, as I told you, the has a, let's say I'm talking about the .NET based applications. That means all related to your .NET based application would be stored in the sense, store in the sense it will be available within your container so that your application can work as expected, right? All right, let's go to the next one. Now, as I told you, we have some of the key components in Docker. Let's say containers. We have discussed, but in the high level, lightweight isolator environments that package an application's core, runtime, system tools, system libraries, and settings. That means, as I told you, whatever application you're running, whether it is Java or Python, if it is a Python means Python related core, basically like your system core tools, libraries, everything should be available within your container itself. So that if you want to next time, if you want to run the application, same application, let's say you have a .NET based application or Java based application, as long as your container is ready, you can deploy wherever you want. That means whichever environment or whichever platform you want to run, you can do so. Okay. Next is a Docker engine. Docker engine responsible for building and running the container. Then who's managing this container? This Docker engine is going to manage these containers. How they can manage it? Because Docker engine work is to basically build and run the containers. That means whenever I run any commands, right, I will show in some time. Docker engine something. Let's say whenever you install the Docker, right, that time Docker engine need to be, it will be installed by default. So when you install a Docker engine is nothing but in our simplest case or simplest understanding purpose, you can think for now, whenever you install Docker, right, by default the Docker engine is installed so that you can run your Docker commands. Then we have a Docker file. Docker file, as I mentioned, a script defining the instruction to create Docker image. Docker image, basically, as I mentioned, whenever you want to create any particular applications as a Dockerize, you want to Dockerize the image. That means we need to have Docker file. Docker file contains your the set of instructions. Now, a set of instructions in the is nothing but, if you take a look, maybe I can just show you one random things. Let's check once if I have anything. Maybe I can go inside. This is about the ASP.NET code. We have a Docker file, right? So within the application, we have Docker file. This is basically a set of instructions. This is a like plain text file, right? That this is self-explanatory. So what it will do first, as you can see here, first from, they will take the base image. Then second is they'll make a directory. They'll expose the port. They'll set some environment, and then again they will set some other basically they'll take base image. This is for a building. You can see this one also, highlight this in comment as a comment. Use the SDK image for building the app. You may see something multiple time, like you can see the from as a from, right? Why we are using? Because as I mentioned yesterday also, we should not be basically copying entire your application code. So only the code I need for particular application to run, those information or those particular libraries or maybe configuration will be copied, right? This is the reason why I'm always trying to set multiple time different way. So from, right? All right, now let's go to the here PT. Okay, now we understood here. Next we have a Docker image. Docker image is nothing but it is snapshot or template used to create a containers. Docker containers, a executable package containing application and its dependencies. And compose, Docker compose is nothing but let's say a tool for defining and running multiple containers application. If you remember yesterday here, we were running Docker PS is nothing but I want to list all the running containers. As I type here, right now I do not see any container running, right? So if you want to run it, but if I type here a is nothing but all, that means containers will be listed including running and stop. Now you can see there are so many, right? So if you have let's say you have one containers running right now, let's say you have a multiple, let's say this is not running, but say for example these all containers are running right now, these all are running, let's say for now. If you have more than, now if you imagine now more than I think 7 8 9, right? So if you had to manage maybe 50 or 100, how are you going to manage all containers one by like manually? That's something difficult, right? So it's not difficult, it is difficult for you to manage individually. This is the reason why even when it comes to the Docker also, what we can do is we can use something called as a Docker Compose. Docker Compose will help you to manage the multiple containers if you have to manage as in one this thing, right? Platform. That is when we can use it. Then we have a Docker volumes. Docker volume persistent data storage for containers. So if you remember, yesterday we were running applications, everything, and now what happens here? Whenever you stop the application, sorry, containers, automatically whatever the data you have within the containers will be discarded, right? It will be discarded because it is not persistent. Only when containers is running and you're working with the container, that time the data will be available. But once let's say the container stop, or maybe somebody killed it, then that time the containers, whatever data you have it, will be discarded. Okay, this is the reason why what we can do is we can use a Docker volume. Docker volume will help us to basically isolate isolate the data from your container. That means just like a separate isolation as a data, what you could storage, so that as and when you want to attach the data basic volume and Docker volume, you can attach to particular container. Let's say you have a two container, and you have a one Docker volume. So whichever volume, whichever container you want to attach the volume, you can attach that. Okay. So it is just like a additional or a piece of a plugin. Okay. That means only whenever I want to attach particular this thing, or if I don't want to miss out my data, I can use a Docker volume separately and keep all my data in the Docker volume, not in the container level. Okay. Now next we have Docker network. We have seen yesterday also already. It's basically for container isolation for and communications. So yesterday also we have already discussed this also, right? Whenever we type Docker network and ls, right, you can see there are different type of bridges we have. So as I told you, this is the bridge that is called as a driver as a bridge type. This is the default. So whenever you create a Docker, whenever you create Docker, by default this Docker bridge will be created basically for you. Docker network bridge basically. Now if you want to see by default this name, we were discussing yesterday also, by default it will be 0. Now if you type here if config, now you can see here. Now whenever you are accessing the application, let's say you deploy the application, you will be using this IP only. And this is a Docker 0. You can see this is a Docker 0 by default. This name will be available. Okay. So if you remember yesterday I was explaining in the module 1, right? Maybe let me just show it a little. Sorry, not module 1, networking, where we discussed yesterday. So if you remember here, bridge network, it is a default one. So it creates a virtual bridge, virtual network bridge, this with this name Docker 0 on a host machine. Host machine in the sense where you have installed the Docker. This is where we have installed Docker. Now you can see the name, this is Docker 0, right? So this is what I was saying you. This name will be created on your host machine where you install a Docker. This bridge acts as a central hub for containers to connect and communicate using the private IP. Okay, address assigned by the Docker internal DHCP. Containers are access the host network and antenna if allowed through the bridge net interface. Now, if you see here, this IP address, as I mentioned, this is a this thing IP address. So we will be accessing whenever you want to access the application through this IP, we'll be accessing basically. So we'll come to that point later, but for now, just understand this one. Okay, let's go to the next one. That is the module 2. Okay. Sorry, not module 2. We are here. Okay, registry. Registry, as name suggests, right? It is a repository where you want to store all your Docker image. That means, imagine now you have a Docker image ready. You have created Docker file. Then you build a Docker image. Your Docker image, where it will be stored? It will be stored in your local. Let's say if I type here Docker image, I will be having the old images anyway. So I have so many images. Now, if you take a look, this one, this is all basically stored in your locator in your local system. Now, say for example, this particular images, one of the images, let's say nginx 10 or maybe whatever, let's say images I have. Let's say I want to share these images to with some of the person or in your team or maybe different team. how are you going to share this one? Because this is stored in a local system, right? This cannot be shared publicly or maybe to a specific person. So this is the reason why we need to define, or maybe basically this particular Docker image should be moved to one of the repository, centralized repository. That means even whenever you want to share this particular repository, sorry, this particular Docker image, the you can share them, they can access it. Okay. So as I mentioned, there are two ways we can do it. There is nothing called two ways, no, but then in the high level for now, there are many platforms where we can do it. Say for example, Docker registry, we have Docker Hub, right? Docker Hub is something we explained yesterday. If you take a look here, this is, I think this is the right, yeah. Docker Hub, yeah. This is a Docker Hub, basically Docker Hub. This is a public repository where you can store all your Docker images and then they can access it. Now, let me take one example. If I talk about Ubuntu also, Ubuntu is this is also already ready one where you don't need to, let me type Ubuntu, right? If you type Ubuntu here, you can see this also Dockerized this, and this is a Dockerized image basically. Okay, this the Ubuntu image, this is already ready. This is also containerized now. So as I mentioned, there is a multiple text, whichever tag you want, you can choose either one. If you want to pull somebody by using these commands, they can pull this image because this is stored in your publicly available, right? This can be accessed by any of the person as long as you have access to the Docker Hub. I hope this is clear. Same way, we have it nginx also. Let's say nginx. You can type nginx here. You can check nginx or maybe anything. If you talk about the MySQL, all the containerized, right? MySQL. Let me check if I'm typing the right keyword. Yeah, I think it's here. Yeah, you can see MySQL, right? So it is clear, right? So if you see here, this is a download symbol, right? That means this many people have downloaded in the sense they have pulled these images from your public repository because this is available publicly. This MySQL repository, sorry, Docker image also, basically, this is containerized, right? So that means anybody can use it. So all this thing, you can see this thing. Now, if you come down here, even you can see the tags as well. They have given a tag also as the database and basically what I call storage related. Now you can see so many tags. So we can go through. Now if you want to use same thing, you can use a Docker pool and the MySQL. This is a tag name. So this tag name, anything that you wish, maybe if you want latest tag or any particular tag, you can choose latest if you want latest. Otherwise, you can choose with a particular tag name. Okay, I hope this is clear. Now let's go to the next one. Next one, as I told you, Docker registry, we have many things. Registry is nothing but it is a repository for sharing and distributing Docker images. As I mentioned, once you containerize the image, that can be shared across the this thing environment, as long as you have the access to the environment. It could be public or private. Now, in our case, public means, as I mentioned, this is a public repository. Private means, let's say I have it here. Let me take you to the Azure portal. Okay. F15. Okay, now we have here also in Azure also, this is a private, again, don't confuse. Okay, the public repository means basically where we can store in the GitHub also. This is one way of doing it. That means one way of storing our Docker images in our public repository. So another way, when it comes to the Azure, we can store in our Azure Container Registry. If you see here, you can simply type Azure Container Registry, right? Registry. Containers, yeah. No, it's not taking. Sometime it's not saying here. What you can do, go to create also. Otherwise, there you can see container registry. Sometimes not anyway. If you see here, container registry, right? This is from, you can see here, this one, container registry. Okay, so this container registry, we can create if you want to create. So this is a, if you see here, uh, Azure Container Registry is a private registry for hosting container image. Okay, using the container registry, you can store Docker formatted images for all type of container deployment. Azure Container Registry integrates well with orchestrators hosted in Azure Container Service, including Docker, Swarm, so many other Kubernetes, everything. So for now, you can think of basically when it comes to the private repository, whenever you want to store your Docker image, basically private repository we can use as a container registry or Azure Container Registry. We can store here. Okay, we will see how we can store that also. In some time, you will see real time also. Okay, let's go to the point now. Okay, as I mentioned, Docker Hub is something the public repository, so nothing to explain here. Now you can go through the benefit. What is the benefit of using Docker? Benefit of your logs, like it is a portability. That means you can, it is easy to access it, right? You can deploy anywhere. You can see, right, run apps anywhere Docker is installed. So as long as you have installed Docker, you can run basically your applications with there. Okay, and consistency, then isolations, and also availability, open source, collaboration. There are so many advantages of using the Docker. Now you can go through the definition later when you get time. Let's not take much. And let's say if you don't have a concept called Dockers, what happens here? Imagine now a traditional way. What happens? Dependency conflict, application with conflict dependency, and portability issue, and the resource insufficiency. Now, why this comes? If you just ask questions by yourself, dependency conflict is nothing but, say for example, you have an application, you have a application running in a particular virtual machine. Let's say this particular person, uh, this is a one, let's see, this is one VM. Okay, now this particular person is working in one particular application. Now imagine now another person also wants to run another application. That means two application I want to run in one system, right? So what happens here, dependency conflict will be for sure to happen, because if I try to run Java basement, I need to install all the Java based related dependency file. Similar way, if I want to install the Python based related applications, whatever the commands or maybe the dependency things, I need to install it. Now whenever as you basically work like this, one of the let's say you have application code also, that time something might have happened. Let's say application having, it is not working for some reason, right? So if you try to troubleshoot, what happened now, if you try to fix one issue, another issue will occur. That is common issue, right? Because it is not isolated, it is using in the same system. So this is the reason why we can avoid using this concept. And also it is not portable, right? So difficult in running the applications consistently across the environment. And resource insufficiency, heavy virtual machines consuming excessive resources. Of course, if I talk about the traditional virtual machines or anything, or traditional way, they consumes a lot of resources. When it comes to uh, the containers, it consumes hardly, it will be in MB size. Okay, we will understand details later, but for now you can see in the high level decision. Excuse me. Okay, now let us understand the difference between virtual machines and the container, because many times we get confused the difference between VMs and the containers. Now, first thing, if you see on your left side is your basically definitions, you can say, right, features, and on this is the basically between the VMs and the container. Let's go one by one. When it comes to the feature wise, this is basically VMs, and this is the container level, and definition emulates a full hardware. When it comes to the virtual machine hardware system running a full OS, right? That means it run the full OS. Each VM has its own guest OS. Before that, I will take you one more diagram so that it will be easy before explaining here. Here you can see. Okay. So this one we have already covered many things like dependency conflicts. We can resolve this one. How Docker can resolve this one, right? Docker encapsulates dependencies within container, avoiding conflicts and portability issues. Docker ensures consistent application behavior across environment. Then resource insufficiency. Containers are lightweight, optimizing resource uses. So if you see this diagram, basically on the high level, this is about your virtual machines. This is about your containers. Now, in the virtual machine level, something called as the infrastructure. Same way, we have a container level also, we have an infrastructure. Infrastructure is nothing but, say for example, in our case now, it is a hardware components, right? What? It is a hardware components. That means container also we have a hardware. You should, that is the minimum hardware component you should have it, right? Same way we have here also. Now, when it comes to the virtual machine, inside the hardware components, what we have something called as a hypervisor. We have it, right? Let's go with the virtual machine first. Hypervisor we have. Inside the hypervisor, we are going to install multiple gas OS in the same gas operating system. Just like how we install, or let's say you have a hypervisor or maybe BM workstation, what VMware workstation, right? So what we do, VMware workstation, we will install that. Inside there we will install the multiple operating system or the gas operating system, right? Same way, when it comes to here, we have something called as a hypervisor. Inside hypervisor, basically what we have is our multiple OS we are going to install. Now each OS operating system, we can have, let's say I want to run the application one. Now all the application one related, you will have binaries files and libraries, everything. That is about the one operating system. Same way, another operating system I have, this will be running for the another applications. Now what you need to understand here is, that means now on the high level, we have a hypervisor. Inside that, we have a isolated operating system. That means now whatever the size we have, it will consume the basically what I call, whatever the kind of the space or the size we have, it will be consumed. Let's say I want to run this OS type, mean it will consume from here whatever whatever I have the size, right? It will consume from here. Same will for the another application and so on, right? Now coming to the containers, we have similar concept, but inside the infrastructure we have only one operating system. It is not a gas OS. It is having one operating system. That means in the hardware, this thing on top of that, basic kernel, this thing, we have a hardware, basically the operating system. Let's say just like in our computer right now, that inside there we have a container, Docker container engine, right? Container engine is nothing but whenever you install Dockers, as I mentioned initially, right? If you're trying to basically run Dockerize, basically container this thing, right? You should install the Docker engine first. Docker engine is nothing but for now. Think that you are installing the Docker components basically. Okay, so once you install it, just like how we install a Docker, right? So in the operating system, inside the operating, we have installed a Docker engine. That means Docker we have installed it. Once we install Dockers, now if you have multiple applications, say for example, application 1 and 2, they'll be having a application 1 can run in the same Docker engine. As long as you have Docker engine is installed, you can install multiple containers, sorry, multiple application can be used or deployed within the what you call operating systems. How is it possible? Only because of the container concept. Because if you remember containers, as I told you, it's nothing but it is a lightware isolated environment where it contains all your system core, libraries, and system files and the dependency things related, right? This all it contains. So that means if you have an operating system, once you install the containers engine, in the container engine, as long as you have installed container engine, I can have multiple containers running. One is for the let's say .NET based container, another one is for, let's say, for Java based containers, another one is for the some other application, let's say Python. So it will be isolated. As the name suggests, container is nothing but it is a lightweight isolated environment which contains your application core, system libraries, or any components or whatever is, right? So this is the advantage of using the containers. I hope this by now you are clear. Now let's go back to the little bit in details. So when it comes to the definition, emulators for full hardware system running a full OS, right? As I mentioned, because you are taking the entire full OS. How is it full OS? The thing, because if you want to run the under gas OS, if you want to run the application, entire whatever size you have, it will consume entire OS size. Whenever you want to run these applications, same way, if you want to run another application, that time also you will be using another application. I mean, it will be consuming entire OS, whatever size you have, consume like that. But where in this case, the OS level, the container level I'm saying will be shared. Okay, OS level will be shared across the environment, in the sense across the applications. You can see here later, we will go through that. Okay, now if you see here, SVM has its own OS, guest OS, as I mentioned, that is what it is. And then it is basically boot time. It takes a minutes. And when it comes to the resource users, heavy needs for more CPU and RAM. Of course, that is required, right, when it comes to the virtual machine. And isolation, strong hardware level. As I mentioned, this particular will be on the hardware level. Isolation will be where, in the hardware level. If you see here, this is a hypervisor we have, right? Hypervisor we have. Here we have everything, right? So here it will be isolated on the hardware level. Now, and then we have a typically size will be in GB. When it comes to the washing machine, it will be in GB. And use cases, running multiple OS types, strong security and isolations. And example, we can talk about the VMware hypervisor or Hyper-V and the VirtualBox in our case. And similar way, when it comes to the container, it is a lightweight shared host OS kernel but isolated. That means it is the first thing, it is a lightweight, and they said the host OS kernel. That means, so where is that? Here we have operating system, right? This will be shared, right, across the it will be shared across the, if you see here, this only having one. Here you have multiple OS inside the record. Here you'll have only, that means this particular OS as a kernel, it will be shared across this thing. Okay, they will share you across basically the environment. Now here, but it will be isolated. How is it isolated? As I told you, because here once you install this, once they set the kernel level, they will set the OS, and they will install Docker container, the container engine they'll install. Inside that we'll have something called as a container. This thing will be running, right? So each container is isolated. This is why they are saying that it is isolated. And share the, as I mentioned, shares the host OS kernel. The host OS kernel they will share across these operating systems. Now, second, maybe when it comes to booting, it will take hardly a seconds. And when it comes to the resource users, it is a lightweight, efficient for use of resource. And isolation wise, moderate. Process level. Okay, using the namespace, we will talk that level or C group. Okay, and typically in MB, when it comes to the size, it will be in MB size. So if you remember now, whatever we see here, you can just take a look. You can see all are in MB size. Whatever image I have, all on MB, nothing in GB, right? So I hope this is clear. So it is quite this thing lightweight. Okay, now coming to the pure. Then it is a microservice. When it comes to use cases, microservices, first deployment, CI/CD, and we have example Docker. When it comes to the container Docker, we have then Docker D and Podman we have. In the high level or in the short, this thing, VMs are better for full OS level isolation and legacy applications. That means if you want to basically have the full basic control over the OS, basically maybe go with the virtual machines and legacy application, right? And when it comes to containers, when should I use the containers? Containers are better for fast, scalable, and efficient deployment for modern apps. That means anything new application which is running in the market now, which is quite lightweight and efficient. For that scenario, maybe we can go with the containers concept here. Okay. Yeah. that's it for here. Let's go to the module 2. As I mentioned, we'll cover this also. Module 2, what we need to understand. Okay, now this will be the our agenda for today. In module 2, what we need to understand is what is image. We understood already how to write the image, we'll understand today. So in today, basically here today we'll learn how we can install, basically we can create a Docker file from basic, and then how we can make use of the Docker file and create Docker image, how we can manage a Docker image, and then how we can also push the Docker image to one of the repositories. Say for example, I can push to the Azure Container Registry or Docker Hub, and then how we can make use of them while pulling it using Docker pull. So we will see now, right? So when it comes to the module 2, working with Docker images, every Docker container is based on an image. Okay, that means every Docker container is based on the image. Till now, we have been using images that were created by others and available in Docker Hub. That is what we are doing, right? So till now, whatever we are using is, this was created by somebody else. That means it is already ready, but we do not know the exact process in order to create from scratch. Okay, Docker can build images automatically by reading the instructions from the Docker file. This is what we are going to understand now, right? So that means whatever instructions you have defined as part of your Docker file, they will read a Docker instruction, Docker file instructions, or maybe you can say as a instructions. Based on that, whatever commands that you have defined in your Docker file, right? Based on the this thing instruction, you can make use of Docker. You can create a Docker image basically. Dockerfile is a script defining instructions to create Docker image. That means in order to create Docker image, you need to have a Docker file. So Docker file is nothing but it is a script defining the instructions, set of instructions. What is instructions also we'll understand. Now, if you take a look closely, we have the, let's say we have a Docker basically file here. We have the build, we have a Docker image, then run and a Docker container. So let's understand this, what exactly it trying to do actually. First thing, Docker file. So whenever I want to, let's say I have a, let me take one simple example of the, I have a Python application, Python based applications. Okay. Now, in order to make use of, basically in the sense I want to containerize the Docker image for my application, that is a Python application, Python based application. So first thing what I need is, based on my existing applications, I need to have a Docker file. Otherwise, let me take one example what I have already, so that it will be easy, quite easier for you. Let's say I have already existing my application here. This is a .NET based application. Say for example, this is the real time, this is the running application right now. But this is written in a code level, but I don't have the, let's say, Docker file, I don't have now. First thing what I need, if I want to convert this particular what I call application, that is a ASP.NET application, I want to convert into Docker image or Dockerize this particular image, or applications. I can make use of Docker file first. That means based on this, whatever the instructions in order to build this application, all the instructions I need to define here. That means while whenever I want to create manually or deploy this application manually, whatever the commands are used, same thing I need to define here also in order to work successfully. Similar way, this is why we call as a Docker file. If you see the name, it is called as a Docker file. And within the Docker file, this is a set of instruction, right? That means you can take the code from here, then you can create the directory, you can expose the port, you can set the environment and so on, right? That means this is set of instructions are defined as part of your application. Okay, so once you define particular application instructions, then you will do something called the build. Build is nothing but Docker build. What Docker build will do is that whenever you basically said, let's say I have defined the Docker file here. Now, based on the Docker file, whatever instruction you given, whenever I run the Docker build, then dash T and then particular this thing, whatever image name I want, they will go through entire Dockerfile repo here. They will check with this name first. Wherever they see this name, this should be in the same project directory. Forget, you cannot keep wherever you want. This should be stored within your project repository. That means this is my project repository. Inside the core, I have a here Docker file. This should be stored in, keep kept in the right place. Okay, so I have kept here. Next is what I need to do is that I need to define all my instruction. So once they will go, whenever I use the Docker build commands, what will do is that Docker will be trying to find with this name, and they will try to read these instructions. Whatever instructions I have defined in my Docker file, they will try to read, understand, and they will try to execute accordingly. That because, as I mentioned, there is a instruction set, right? First you can get an image from here, then after getting this thing you make a one directory. This is where in the container level, right? Then I need to expose the port, then I need to set some environment like that. All the instructions are set, so they will read this one and execute accordingly. I hope this is clear. Once it's done, the Docker, then what will happen is Docker, once you run the Docker build, Docker based on this Docker file, based on the instruction that you define a Docker file, whenever you run a Docker build, then Docker image will be created for you, right? Docker image will be created. Now, once Docker image is created, what is the next now? I need to now, just like here, right now, if you see Docker images, right, we can see these images like that. You will be seeing something like this. Now, question is, this is stored in a locally, right? Now, but how can I deploy this particular application? Maybe yeah, this particular application, how can I deploy? Where can I deploy? Right, this is where I need to, where can I run this one? That is why we can run into our containers by using Docker run. Whenever I run Docker run, what happens? Docker run and I need to expose the particular port, and also local port and the container port I need to expose whenever I run. If you remember yesterday I have shown it, but yeah, I can maybe show you once again, so that it will be, let me open one more tab, maybe duplicate I'll do. Now if you see yesterday, we were discussing, right? Yeah, if you see here, this one we understood, this is from the public, you can see, right? Docker run, whenever I do run a container, now with the name of the container, and this is basically data more terminal, I am trying to expose the port, p mean port, and particular this is a local port. Local port in nothing but this is the host machines where your containers are running basically here. This in containers in the sense your basically your store your this is where we installed the Docker, right? So this is a host machine. So this particular port, this is a inside the container where the application is running. This is a port name that and what is the name of the image? This is the image name. So if you run this one, what will happen is that it will create a containers with this particular container name. It will be in a data mode. Why data mode? Because I can run this particular container in the background. If you don't use the D, what happens? You will be inside the containers only. That means you cannot execute, you cannot work on other things. So this is the reason why I use a D, that is a data mode, so that I can do some other, or I can execute some other commands. Okay, fine. Now let me coming to the let me close this also. Okay, now once we have one done this thing, now as I mentioned, now Docker containers can be run here. Okay, this is a high level. Anyway, I will show you in demonstration. Now let us understand what are Docker images. Lightweight standalone executable packages that includes everything needed to run a piece of software, including the core runtime libraries and system tools, right? So that means, as I mentioned, just like here, we have a Docker file, then we will build that one. Then Docker image will be created. Then Docker image I can run the Docker into the Docker container using Docker run. Then I can define the container name, then we can deploy wherever you want. So whenever I use this thing, so what happens, it contains your all your, it is a lightweight standalone and executable packages. Executable package means it is a piece of code basically that contains, that is required for your application to run, such as you have that application like runtime, right, core and runtime and libraries and system tools, everything will contains. Okay. Okay. Image layers. So image layer also it is, I will just give you a high level. We should not be going that deep. Docker image is built up from a series of layers. So whenever I basically build a Docker build commands, right? Docker build commands, if I use, what happens? There is a something called as this layers. We have multiple layers here. If you take a look here, each layer represents its instructions in the image Docker file. That means there is something called as a thin, that is a read write layer, that is a container level, and we have multiple layers. This is all called as a image layer or read only layer. Now what is read only layer? Read only layer is nothing but uh, read only layer is nothing but anything that is already created that cannot be modified, right? That only you'll have only the read permissions. Permission is not about the permission. Basically you cannot modify anything once you created the image basically. But then yes, on your high level thin level, that's a read write layer we have, that is a container level. You can change later the name of the container, maybe if you want to, or image if you want to change. So okay, now in the nutshell, now if you see here, from the, it will always come from the below, like not the top level, it will come from the bottom level. If you see, based on Ubuntu, let's say this is basically container, right? Now partial Ubuntu means basically this is a from, right? So if you remember, we define multiple containers instructions, sorry, Docker file instruction, right? First is a from. So from basically, if you remember, till now whatever we have defined here, um, here the from is always fast, but when comes to the layers, this will be always it will start, it will start from the bottom, not from the top. Okay, so what is saying, whatever you have defined this thing, this instruction, once it is created or the Docker file is created, so not Docker file, Docker image is created, it cannot be modified basically, or cannot be changed anything. Okay, right, now let's go. Now in the nutshell, images are like a Lego blocks forming that base of the containers. The thin read write layer is like a notepad for temporary changes. So the container layer is like a configurations file for the individual containers. So you can take a look once again this properly definition. As I mentioned, this is a top level, a top layer. This is a bottom layer. This is you can have different layers basically. Go through this basically this thing. Nothing to explain. I will show you anyway demonstration. You can understand that time. Okay. You can go through when I get time here. Now, difference between Docker containers and Docker image. Yeah, in the high level I'll explain. The major difference between container and the image is the top writable layer. All writes to the container that adds new modify existing data are stored in the this thing writable layers. Now if you just take a look here, this is the official documents basically. You can take a look later if you get a time. If you see, this is given as a like top level, right? Here we given as a from, right? So this is a from. Here we have given the after from. We have defined certain layers. Layers means what is the layers? Missing nothing but this is one layer, this is another layer, this is all layer. This is called as a layer. Now that means, just for example, this here, how many layers we have? Total we have one layer, two layer, three layer, four layer. Total we have four layers. But whenever the Docker specific try to say, the top layer will be considered, it will be read as the bottom layers. Opposite will happen, right? So that means always whenever you try to run the commands, let's say you try to run commands, let's say I want to install and also I want to update and install. So what we can do is, if you remember, I don't know how many of you are aware of the Linux. Um, let's say I want to install something, apt, apt, then then install whatever. Let's say I want to install. Let's say I want to install something using apt commands, right? Apt basically the this thing. I want to install something in the Ubuntu. After basically updating, first I need to update, then I need to install, right? So what we can do, like example, I have run the command, first command, then 1, then I can use this command then 2. That means first run the a commands, then run the b together. So what happens here, this all together will be considered as one layer because they are in the same layer. That means similar way, whenever I want to write a Docker file, if you notice, let me check for something. Yeah, I don't have anything, but yeah, just think example. Now I have one more user directory here, right? Let's say I want to give some, I want to update something. After 3, I want to update something. Let's say I can give some comments together. Okay, so that what happens here, the layers will be considered as one. Now that means here only one layers. This is one. That means 4 layers I have. And now if I want to reduce, if I had to run another comments means instead of defining another layers here, I can somewhere related things I can update here one more comments in the same layers so that they can reduce the size of the image, Docker image. We will see that this also later. Okay. Okay. Now let's go to the here. Yeah. Now let's go here over instructions. Okay. Now let's understand Dockerfile. What is Dockerfile? It's nothing but it is a instructions arguments now, right? Always we have a from as we are from also it is instructions. From nothing but the from instruction sets the base image for subsequent instruction in a Docker file. That means this is very important. Basically from is something that is your base image, basically from where you want to get the basically the image from, right? So as I mentioned, for every single Docker image has a base image, right? It's built up from the image, right? So this is why we have to select the image when you define a Docker file. Now we have a uses example from, we can have an image name, we can define a tag name. Example, we can have Ubuntu, you example 1 2, then we can give it some name, example like that. Okay, same way I don't have to explain this one, you are already aware. Then we have arguments, instructions. Here you can see here definitions. The argument instructions allow you to define the build time variables. If you want to define, let's say argument versions, letters, something like that, you can define, right? Similar way, if you want to define the working directory, which we shown already, so we have another instruction, argument instructions, where we can define the working directory or work directory. Instruction sets the working directory for subsequent instructions. Say for example, I can give a working directory space, then whatever the directory name, right? Something like that I can give it. So just go through everything. Then run time. So run means why run is used. Run also it is a command, right? In Linux, when it comes to the here, it is known as instructions. Now the run instructions executes commands in a new layer on top of the current image and comments the result. So basically, as I mentioned, you can use something like this, right? I was telling this one. Now let's say I want to run some commands. If you remember, run is basically these arguments. This is actually commands, right? Space apt get update. This is a one command. That means this is going to update the command, basically the whatever changes. I mean latest one. They're going to update one. At the same time, I can install apt get install the y what I call nginx, right? That means at the same one line, I can, or I can say as a, this is called as a one layer, right? Whenever, if you remember, this is one layer. If you want, you can define this is one layer. Same way I can define this another one layer. But what I did was, with the help of double listing, I used it here so that I can run two commands as one into the one particular layers. The reason why I define in one layer is because to reduce the size of the Docker image, because the more layer increase, the more the size will be increased of your Docker image. Basically, this is the reason. Okay. Okay, next we have copy. As name suggests, right? Copy definition. The copy instruction copies file or directory from the build context into the container. So whenever a copy, as the name suggests, right, you can copy, if you want to copy from one source to destinations, maybe you can use a copy so that you can use something like that. Let's say you have an example, you want to copy, what you want to copy, this is a source directory, right? What is the source, where you want to copy, source destination. This is a source in the same directory where it has to copy particular directory. Okay, then add basically instructions. The add instruction copies files, directories, or remote URL from the build context into the container. This is basically add is basically more of you can think for now that if you want to remove the URL, basically if you see here, instruction copies, directories, or remote URL. Remote URL means something that is not available in your locally. You want to be using store.1, we can go with this instructions add. So just go through everything on stream because if you see here, they're given something like this. The URL is given where it has to be copied, everything, right? Go through instruction. Let's not discuss much. You can know, this. Go through everything. Let's come to the expose also to expose it. Let's come to the directly. Okay. Tagging. Okay. Overview. We have understood this thing also. Okay, let's go with the tagging. Tagging also why we use. Tags can tags help identify and differentiate different version of an image, making it easier to work with and share. So basically, if you remember, whenever you want to work something, you want to modify something, right? If you do multiple changes, how are you going to make sure the changes, particular changes, right? So it's quite difficult. This is why for every single this thing, you will have a Docker basically image ready. Let's say if I type here, if you see here, I type Docker images, you can see the, let's say I'm talking about nginx, we can see the tag, this tag version latest. Same thing, we hello world, this using a latest. Maybe this not about the latest, you can give any name as long as you need, whatever name you wish to give. Okay, so this is the reason why we should understand the tag benefit of using tag, because the same image if we have multiple different version, let's say I have an nginx 10, I have a multiple different version, that means multiple time there is a changes multiple times, right? So how are going to understand the changes? Now if you have a tag based on the meaningful tag, it will be easy for me to identify for specific changes. This is the reason why we can make use of tag. Okay, how to tag also I will show you, no worries. Docker commit, managing image, manages image already I will show you. Okay, now what we'll do, um images, how to manage it. Yeah, this one already we have seen yesterday. This also not required, managing it, Docker registry. Okay, what we will do now, pushing we will do Docker registry. Okay, first thing now what we will do, we will see now how we can create Docker image, Docker file. Now this is my this thing. Now what we will do, we will try to see, we have one Docker file created already. Okay, now we will see that how we can create the base from the, how we can create a Docker image from the Docker file. Then how we can manage them, how can we can tag them, how can we push them to the particular repository, we will see this also. Okay, so let's get started. Now as I mentioned, this is the this thing I will be using it. Now if I type maybe ls, I want to see here I have to let's talk about the nginx now. If I talk about nginx, let me go inside cd. Nginx is something I want to go inside, because within the nginx, this is a directory, right? I have some folder, like in the sense directory, I have two things. One is a Docker file. As I mentioned, wherever you have the repository, in the repository level or maybe a project file, you should have a Docker file. Remember one thing, the Docker file name should be as it is. Don't try to make a small letter the D. Try to always use the same best practice, that is Docker capital D. Okay, Docker file same as it is. Okay, then HTML. HTML first, let us see what we have in the Docker file. Cat, I can use a Docker file. Now what will happen? I can see the what contents we have in the Docker file. Now, if you see the inside Docker file, if you see inside the Docker file, I have it from, I'm taking the latest nginx. And what I'm going to do is that I'm going to copy the static HTML content into the nginx container, because I want to make use of the nginx containers, but like HTML content. Contain means HTML related, whatever code I have HTML related, I want to copy where? I want to copy this whatever I have in the same directory. If you see here, this is the name, right? This is directory name. That is why I given the dot slash. And this directory name, where it has to copy, inside the nginx, there is something called as in the container lab. Inside container, I have a slash user, then slash share, and then I have nginx by default. This is the default nginx directory. Inside here, by default, I have HTML. I want to copy paste this here. This is the reason why I'm copying. That means I want to copy this particular. Sorry, where is that? This particular file, whatever context I want to copy to containers inside my nginx container. Okay, in particular directory. Second, once I do this thing, as I mentioned, in order to access the applications, I also need to expose the particular container port, right? So this is the reason here. This is a container port, not remember, not a host machine port. This is a container port. That is where your nginx is running. Now, this is the reason why expose the port 80 default port for HTTP, because nginx use as a port 80, but as I mean, you can also change it according to maybe applications. Now, this is the reason why this is another instructions that is called as a 80. I mean, that means I'm trying to expose port 80, that is for the nginx. Now, once this I have done, now this runs by default. No need to define the entry point explicitly. Now, entry point is something, if you remember other applications, say for example, here we have entry point somewhere, I think. Yeah, entry point is defined. What is entry point actually? Entry point work is to basically, once the container is basically created, it has to restart. But by default, when I talk about the nginx, you don't need to restart the containers. By default, they will get restarted by default. So this is the reason why I have not defined here. But then, yes, of course, many of the Docker file, end of the Docker file, you will get to see something like this. That is a entry point. Is almost every single Docker file, mostly it is being used, but in some application that is not mandatorily required. Okay. All right. Now that means we understood. Now, okay, that means in the container level, so the Docker file, I have only this small piece of code, but it has a so much power. Now, as I mentioned, this is a small, we need to understand the basic first. That is the reason why. Okay, now let me see what contents we have in our HTML then. Cat HTML, if you type here, now, sorry, it is not a, it is not a, what I call, direct file. It is actually directly. So we need to go inside that one. So let me come out of that. Right, I'm inside now. If I type here, this is actually a direct, sorry, I need to go inside my bed. Okay, now I need to go inside this directory, because inside this direct folder, right, this is a folder, or in Linux case we can call as a directory. Now you can go inside HTML. Okay, now if you go, if you type ls, now we can see index.html. That means what index.html, basically if you go in the nginx also particular directory with the same name, the contents will be there. Now if you want, let me show this now how we can check this one. Now as I mentioned, we can go using cat commands so that you can check the content of this particular HTML. Now, as you can see here, inside this here, I have it, the code system type, and you can see here, whatever name you want, nginx, welcome to nginx, hello Azure DevOps files, this name I have given. That means this is a simple piece of code. You can give anything you want, but the syntax should be correct for HTML related, because it is for the nginx. This particular code, if you want, you can get a lot of template outside this thing. Okay, you can just search it. So I have taken same way. I have not created this one. I have taken some sample code. That's it. Okay, that means that right now I'm going to copy. So let me go back. That means what is our agenda now here? Our agenda is to basically read the instructions in your directory, that is in the same directory, project directory. I have a full Docker file with this name, Docker file. It has a set of instructions, and I want to copy the context from the HTML folder in my HTML nginx, basically this thing container. So what I can do, how can I do that one? In order to make that one, let's go. I can go with the step by step. I will maybe follow the instructions defined here so that it will be easy for you to follow. In the module 2, if you see here in your repository, right? Create image and manage. Now let's see now. Now if you come down, same similar way, I have taken one code. You can go through this code, what it does. You can read all self-explanatory. You can go through. But as I mentioned, we have it already, code is ready. Now what I need is this all ready, right? Step 2, because Dockerfile is ready. Now build the Docker image. Now this is what we are going to do now. This focus on building Docker image using the instruction provided in a Dockerfile, right? Because in the Dockerfile we have given this thing. Now, now I have to use the Docker build, and the T is nothing but it is a terminal, and this is the name of the image and the latest. Question is, what is latest? Let us understand this one. Let me copy first this one, or you can type it if you want. You can type it. Okay, in my case, let me type this one. But in your case, you can copy paste if you want. Docker build is to build the Docker image basically, right? Docker build dash T terminal. Next, I can give a name of the image. Now, I want to build a I want to basically build a Docker image from my based on the Docker file, right? But in the Docker file, what is the instructions about? It is about the nginx, right? So it is that means the Docker file instruction is given for nginx related. So Docker image name, I can give any name that I wish to give. So what I can do, I can give something related to nginx. Nginx, let's say I can give as pulse. As I mentioned, Docker image can be given any name you want, but once you give this name cannot be changed. This is what it is. Okay. But if you want to create new image, yes, you can create with different name. But once you create with the same name, within the same Docker image, you cannot change the name of the Docker image. Now, as I mentioned, let me type here. Now, as I type here, I can simply use a dot here, enter. Why I use a space and a dot? You should not use, this will not work like this. This will fail probably. You can see here, this will fail. So rather you have to give space. But before giving space, we need to understand one thing. Do one thing. Let me create two Docker image. One is with this name, Docker Pulse. Maybe I'll give as a 101. Okay, this is a 01. I'll give this one. Okay, I want to show you a different way. Now let me give this name. Maybe let me. Okay, anyway. Now what happens now? If you see here, yeah. Now if you see here, Docker build using this one. Now I given the Docker image name as the Pulse in this particular directory. That means space dot is nothing but the Docker file basically contains within your working directory, right? If you check here, you can type ls, right? You can see Docker file is in the same directory, right? This is the reason why I'm giving this one. That means, as I told you, it has to be located. Docker file should be stored in your right place. So this is the reason why I'm giving here. Now, one thing, if you notice here, I have given the Docker image name, but if you notice here, sorry, where is that? Here, I given that latest. What is the latest? Latest is nothing but it is the tag of your specific Docker image. That means if you want to define here also like that, right? I can define. It is not about the latest. You can give any name as long as you need, like word.01, something like that. Sorry, version 1.0, something like that. Anything I can give it, but space is something that you need to keep. This is the basically image name, Docker image name. This is a tag name. Try to use this colon always. Don't forget, otherwise it will not work. Okay. Now, one thing what you need to understand. Now I'm using a tech now version 1. In this case, I will do. That means right now I will have a two nginx pulse will be created. One is a pulse 1, second is a pulse 2. But let's see what happened. By default, whenever I do not define any tag name, I'm saying it, whenever you create a Docker file, if you do not define the tag name by default, Docker will still map with the latest name. That means if you don't define uh, with this name, still once the Docker file is created, they will map with this name, same name. This is the default behavior. But in my case, I am right now trying to do that is a pulse 2 with another some Docker, some different tag name. Now let's see what happens. This will be created. That means right now I have two Docker file created with the nginx pulse 1 and nginx pulse 2. But in the nginx pulse 1, I did not define the tag name, but here I have defined a tag name. That is a version 1. Now if I type Docker images, or yeah, Docker images. Now let's see what been done. Now if you take a look here, this is what we created first, right? Docker, sorry, nginx pulse 01. If you see here, as I told you, this is our latest. This, if you remember, I have not created this one. I have not defined it, right? See here, I have not defined it. When I use pulse, I simply created that. So I did not define any tag name. But by default, Docker will try to map you with the latest name. But if you want to define, or instead of that latest, if you want to give any other name, you cannot do so by default. So you have to explicitly mention if you want to define the tag during the Docker build. Okay, so that is where I was trying to make you understand. If you see here, pulse 2 or pulse 2, this is the name I given, if you remember here, because as I mentioned, I want the tag name to be specified with this name. So this is the reason why I have got this name. I hope this is clear till now. Next, what is the next thing? Right now, we have created a Docker file, right? Sorry, not Docker file. We created a Docker file also already created. We created a Docker image also from the Docker file. What is the next now? Next, we will see the tag. As I mentioned, tag is dead. Let us run this application. Let us run these applications. How can I run? Can somebody tell me the commands how to run this container now? Means this image is there, how to make use of the Docker container and run these applications. So in order to run, let me take example of, I will take this one. I will run the application, because in the applications what contains it has, if you remember, we have it HTML something nginx, right? Nginx something we have. Where is it? Okay, this is nginx, right? If you see engine HTML. Okay, let's not go inside. Okay, I will show you anyway. That means we have already seen, right? Inside this particular directory, basically HTML, we have nginx related HTML code is there, no? That contains about Azure DevOps related. So I will show you that also. Let's not go for now here, but I will show you this also. Yeah. Now we have got the image ready. Now we need to create Docker containers. How can we create Docker container? To create Docker container and make use of, once I create Docker container, I can use this particular or deploy this particular nginx pulse 1 or 2. One of them I can use it. Let's go. Now Docker run. Now Docker run, I can give a double dash name, n or name I can give. What is the name now? Name is something. Okay, here also I will make you, or I'll show you two things here so that you can understand. I will not, let's not do make, otherwise I'll copy to save some time. Maybe we'll start. Okay, no problem, directly I will do it. Okay, that means I will use the D, Titus, T for terminals, P for port, right? Now I can give a, in this particular system where Docker is running, what is the port I want to expose to? Let's say in my case, I'll run 800. It's my local port. And this is the then remote port. What is the remote port I want to define? I want to define, let's say 80, because nginx listens on port 80. Now, what is the image basically I want to get to? I want to get the image of, let's say I want to get this to this name, right? I'll copy this name. Then what is the tag name? because if you have multiple, they will get a latest tag. But let's not this thing. Let me take the latest tag name v1 dot 0, right? That means what I'm going to do, try to understand one thing here. I'm trying to create Docker container based on my Docker image, that is a nginx pulse 02 with a particular tag name. Here, now if you try to understand one thing here, I'm trying to create Docker container, but what is the name of the Docker container? I have not defined it. Let's see. I have not defined a container name. Now if I type the Docker PS, because PS nothing but the running container, I can see now. Now, if you see here, this is the container ID. Same thing, maybe if you want to check container, this is a container ID got created. This is the image I got tried. This is the image I took now whenever I create, if you remember, this is the image I used it. This is why they are using this Docker image name. And this is the command by default, they will take care. This is got created 30 seconds ago. And then port, as I mentioned, 80, I have exposed it. This is a port 80, and this is a like container port, that is a port, sorry, 800 is a local. This is the container port, as you can see here, right? And if you see here, what is this? This actually a container name, but I have not defined any container name over here. If you see here, anyway, I have not defined. But tell me one thing, in real time, do actually we know, I mean, do we really define or use like this? We don't do, because this got created by default. That means if you do not define the container name while creation of the container, still Docker will try to create some random container name. Okay, now okay, you understood, now we understood, right? Now let's see one more thing. Okay, now let me create my desired name now. Okay, I don't want this name. Let's say now if I want, I can delete this one, but let me create another container. But this time I want to create a container name as well. How can I do that one? Simply before the run, you can use a double dash name or n name. Now I can give a name of the container, right? Name of the container. In my case, let's say I can type let's say a container pulse, let's say 01, let's say. This time I given the container name as a container pulse 01. But one thing, this will also will create. But in our case now, if I type here, this will not create. The reason, you know why it will not create? One thing we need to understand is that even if you're working locally, this is, as I told you, this particular port, that is a port 800, this is a local port, and this is a container port. So this container port can be used n number of time. That means as long as you need, whenever you want, according to the application, because this listens on the nginx application, right? So this port can be should be defined as it is the application. But when it comes to the this work container sorry host, system host, this particular port, this cannot be same, because this has to map. That means this local port has to be mapped with your container port. Now you understand, right? Now if I try to run, now they will say that this particular port 800 is already used. Let me show you. Commands wise, everything is working fine. But as I told you, this port is used. This you cannot use this port again and again and again. Now let me show you. Let me type it. Let's see what is it now. As I told you, you cannot create the this time, because the reason, if you just go through the error, this if you try to create, it is Docker error response from the daemons fail to set up container networking driver fail programming external connectivity on endpoint container. This name be given, right? Container pulse 01 is what be given name. Now what is the reason? You can see here, bind for this particular port 800 basically fail. Port, this particular 800 port is already allocated. You understood? This port is already allocated. That means we understood now. So we cannot have the same port use multiple times in your local system. So this particular port should be different. Now, before that, let me see the PS right now, how many is running. Right now, only I have one, but let me try with the A, including the non-running also. 800 nginx pulse. Yeah. Okay. Now this is all we have. Now what we can do is, as I told you, we only have one here. Now let me change the name port now. As I told you, this particular port 800, that is a local port, is already being used or allocator. Hence, we cannot use the same port while using it for another container. That means for each container, whenever used for particular nginx or whatever application, should be unique port, not the nginx port. I'm saying the local port. Okay, now let me change this one. Now let's see. Okay, this name already taken because it is trying to create. I will give this time 100. Now you see. Okay. Now I given this name. Now you can know. That means because this might be created in the backend, but then it will not work as I told you. So now I'm trying to change the country name as 11. Now with us 11, this particular image itself. Now you see here. Okay, now this will work. Now if you see here, I didn't have an issue. Now if I type the docker ps, now you can see the desired name that you define. Now if you see, first whenever I run with this particular container id, this same both are same image, right? But if you remember, this is 5 minutes ago, this is 10 seconds ago. So yeah, if you see here, this is the previous one. This is the name of the container, but this is the name that I have defined it right now, 11, right? 11 name. This is the container name I have defined it. That is how I have defined it. Okay, now that means your application is running right now. I mean, it is running already. Container is running. That means your application, that is your this particular image is already running inside your containers, right? Now, how can I access this one from my portal? Basically, here there are two ways. One is using curl commands. Curl is nothing but client URL. What is client URL now? Let me show you. Now, how can I access the application? As I mentioned, if I see the application level, what contents we have, let me show you in the nginx what we have actually. Maybe go. Let me go to. Okay, directly I'll show you. To access this application, you can type, as I mentioned, two ways. One is the curl co, okay, curl client URL. Then I can mention HTTP because it is not a S colon double S local host, because we are accessing locally. Local host. Local host I given colon, and now I need to define the port, because if you remember, now which one you want to access it. There are two applications. I want to access this one or this one of them. Let's say I want to access this one. If you want to access, what is the port number they have, they are listening on? Port number they are listening on 801. So I need to define 801 port, because as I told you, for each applications, if whenever it is mapped, it will be used in the unique port. It should be mapped from local to the particular nginx or whatever application it is, right? So as I mentioned, I map this particular port with my nginx port 80, right? So now I can be able to see. Let me show you. Let me type. You can see here. Now, as I type a curl, I can access my applications, right? That means your application successfully running. Now you can access local here. Same way, this is one way of accessing within your system, basically in your this thing command line. Now, other way of accessing it, if you don't want to see like this, I can simply copy this one, same as it is. Instead of the curl, copy this URL and then go to the web browser. Maybe I can go. Let me take here. Let me expect this thing. Now you can see here, right? There is a two port 101. It is taken the 1 minute. It is taken the old port. Let me. Okay. If you see here, the first is it took the cache from cache is taking, but it's not the right one. This is the old one. So now you can see, right? Now this is the name we given, right? If you remember, what is that? Yeah, this is the name we given, right? Hello, as you was Paul. This is server nginx. This is the name we have given here. If you see here, so now we understood the two way we can access it, right now. Okay, that means right now we have understood how we can basically run the applications and also access the application. Now let's say how can we manage these applications, because this particular application is working fine locally, but how can you make sure this application can be published remotely or centralized location, so that even other person can also uh, use this application and work on that particular this thing, right? How can we do that? So the first thing what we need to understand here is that, let's go the documentations so that it will be easy. Now coming to the point 2, I mean module 2. First thing, as I told you, I have already seen the Docker image. We have these many images. Let me take one example, one image. Let me take, in our case, I will go with this one, nginx pulse 2. That means this nginx pulse 2, I want to push this one remotely also. Remote means repository, that is your um, GitHub, sorry, not GitHub, Docker Hub, as well as Azure Container Registry. Let's do that. So in order to basically manage in particular this particular images to centralized location, first thing we need to understand this particular image is a tag or not. In my case, this all a tag. I'm good here. First thing, as I told you, by default it will tag. Second thing is that I need to map this particular Docker, this particular image with my repository. This thing I need to map them. How can I map them? Let's see that. Um, I think I should be giving the instructions. Maybe let's see. Otherwise, we can follow along. Um, yeah. Okay. If you see here, now if you, this is the thing we have done. Now you can see the option pushing to Docker Hub. Now, as I told you, image ready. Now we can push this one. In order to push this thing, I have to log in here, because I need to log into where? Docker Hub, because I should have Docker Hub ready, right? In my case, I have Docker Hub ready. Let me show you. This is my Docker Hub account. Now let me refresh it better. This is my Docker Hub, and if I go to my let me go back. This many I have it. Let's say I want to do it. One of the things, there are so many things, old, new. I want to push new code basically. If I check what is my, this is my ID basically, copy. So what I have to do, I have to log in, right? Well, I have to basically authenticate, because this is public means it is not mean that you still need to have the ID, right? So this is the reason why I need to log into my Docker Hub first in order to push this image to the Docker Hub. Docker login dash u. Dash u is nothing but user. I am defining it. And in my case, name of the user is, this is the name I given, right? I entered. Now it is asking me like I can define the password. Password in the sense Docker Hub password. What I, so Docker Hub, whenever I log in, right? What password I can create? Otherwise, it is showing that a personal access token, a PAT, can be used instead. This is the best practice they are telling. Okay, then I would also be preferring to use the Docker this one. How can I create a PAT access now? If you're coming to the Docker Hub login page, I mean your home page basically, there you can go to the your profile. There is a settings, right? Account settings. Go there. Once you go to the account setting, there is a personal access token. Click there. As you click here, there is an option. By default, it will get created. But as I told you, I'm going to create new one because I don't have it. Because this access token, once you close the browser, you cannot be get the same access token again and again. So maybe you have to secure this particular token file somewhere safely. Okay. In my case, I can give anything. Let's say I can mention Docker pulse. I'll mention just for test this thing. Expiry I don't want to define, or I can define according to your requirement. Let's not set any expiration. I can maybe give as the every single permission, depends on that one. Because I'm the admin, so I can give full access, no problem. but depends on the case. You should be careful while doing it. So I will give it. As I give the access token, now if you see here, I have already to run. They are telling to run this one. I have already run this one, right? If you see here, I have already where is that? I have already run this command, so I'm good with this one. Second thing, I need to copy paste this one. Now they are telling copy at this at the password from enter the personal access token. So this is what I'm going to do now. So let me enter it here. Sorry, it's not taken, I think. What happened? Did I not copy properly? Let me copy. Let me 1 second do, okay? Let me enter. Okay, now as you can see, I have successful login. That means now we have understood how to authenticate from your local system to Docker Hub, right? Now it's time to tag them. Why tagging is required? Because unlike you tag from your local system, from local where you have the repository, right? I mean, not repository, code basically. That is a Docker image that has to be tagged with your Docker Hub account. So let's for that. So how can we tag them? So in order to tag them, I can close this anyway. I don't need for now. Yeah. So tag means why tag is required. Let's follow the, okay, here. This is done. I have given this thing. Now I can give a tag name. Now this is done. Second thing, tag your image for pushing. So whenever you want to push to the Azure Container Registry or the Docker Hub, your Docker image must be tagged with your destination's repository. That means if you're pushing the tag to your Docker Hub, means you have to, based on Docker Hub, you have to tag them. How can I tag them? That's very defined. Like Docker tag and name of the your applications. This is for the Docker Hub, right? So Docker Hub, your tag and whatever tag name you have and username, this thing. So in my case, so what we can do is I can, so which tag I want to push this one, right? I want to push this thing. So what I can do is copy this name. I can simply tag them first. If you see here, this particular, this no nothing with this name, right? Let me tag them. So how can I tag them? As I mentioned, Docker. I have already logged in, right? Or no, Docker tag. Then what is the image name? This is the image name, right? And I can define the, in this particular, which one I want in my case. If I want the latest one, B1, right? B1 0.0. Now this particular tag, this is the tag that I am specifying that I want to tag this particular image. But to where? What is the destination you want to push to? So as I mentioned, whenever you want to push, you have to tag them. So I want to push this one into my Docker Hub. So first thing I need to authenticate. So in my case, I have already authenticated, right? Now, what is the username of the Docker Hub? Now, in my case, if you remember, this is my username, right? Copy the username. Then slash you give. Under username, now what is the tag name? Now, what is the name? I want to give this name. Slash this thing. See, this name, remember one thing, this name is your look from locally, whatever name you have, I have defined. But in your remote, that is your Git Docker Hub, if you want to change the image name, according to your this thing, you can change it in your Docker Hub. That is your optional. But if you don't want to change it, accordingly, you can keep it. But in my case, for your better understanding, I can show you this also. I will change this also. Instead of 1, I can give 11 maybe. But carefully remember, it is this one is you have to define whatever name is there. I'm trying to define only in the Docker Hub related, in the Docker Hub, not in your locally, because this is the remote, right? Your username, Docker Hub username, your image name should be careful, same as it is, and whatever name is then. Even this name also, as I told you, you can change any name as long as you tag them. Even if you want to change this name also, you can change it. Tag name, image name, you can change it. But in my case, let's not change much. For understanding purpose, this is okay for me, for us now. Okay, now as you can see right now if I type the Docker images, now you can see here, right? This is the name. This is the pulse 2. This is coming from where? This is basically we are tagging this name, right? This is the tag name. This is the username of the Docker Hub. This is the image name, right? Tag name, as you can see, your tag name. But then if you see here, this tag name is different because if, as I mentioned, this is from Docker Hub related. Now, okay, now we are good with the tag. Now tag is done. Now what is next? Now next is to push the tag. I mean, not tag, the image basically, Docker image. How can I push? Same simple Docker push. Now, then next what I want is once your tag is completed, you copy paste this name. That means the repository you tagged it, tag with. That means first your username, then your image, then you can give a maybe this one, whatever the ID 11, right? Copy this one. Okay, I'm good here. So once I do this thing, let me see here. Now that while pushing in a tag, this name will be available in your Docker Hub. Now as you can see here, it is right now mounted showing. It takes some time, maybe at least 30 seconds to 40 seconds, depends on the size of the Docker image, right? So yeah, maybe we need to wait for some time. This many size we have it. This image is created by ourselves, right? This is we didn't use the publicly, but we created using Dockerfile. So we define the Dockerfile first, and then we build a Docker image, and we test it also. Later, we want to manage the Docker image in our centralized location. This is why we are doing now. Basically, we are pushing this one to the Docker Hub, so that even if you want to use now this particular Docker image, I mean this particular image, you can make use of them. Oh, why is taking time? Okay, sorry, I was just okay, done. Okay, it's done. Now you can see here, this is done. Now let us go back to the Docker Hub. Where is Docker Home? I can close this anyway. Now, okay, let's go to the here console Docker Hub. Okay, now you can see here. Okay, 2 minutes ago is got created. Whatever name I given, my username, everything. This is coming from where? This is coming from our local Docker image. Okay, now let me click here. If I click here, whatever tag name I given, right? This tag name. This is a tag name. We have defined it here, right? Where is that? Here. This tag name. Not this one. This name is sorry, not this one. The name is different. Okay, so whatever tag name you define, that name will be pop up here. I hope this is clear. Now, same thing, if you want to make use of this one, you can directly, what you can do is you can use the git pull commands. Sorry, not git docker pull. You can use this particular thing. Okay. All right. Now you understood how to use basically push this image to the Docker Hub. Now let's check how same way how we can do basically how we can push the Docker Hub images. Sorry, Docker images. Sorry, Docker images to the container registry. That is Azure Container Registry. Okay. Maybe I'll just complete soon. Yeah. Now as I mentioned, I'm trying to create new one. I will come to here. Here, then I'll try to create one. This is the private one. What we have done right now was publicly available. That means anybody can access. But here, other person cannot be accessed. So I can just mention as here RG, something like that. Any name you can give. I can mention as here Pulse, DevOps Pulse. DevOps. DEB was Pulse. 100. Okay, this is name again. In our case, let's not think much about the security or other thing because our work is to understand for now. Okay. So I will go with everything. So I'll go with the permission as the RBAC. Maybe plan I will go with the basic or standard is okay. I can go with the basic maybe for now. I don't need advanced one. Let's go here. Also, normally if you talk about the in the real time, they will not use like this. There will be so many security things that we need to keep in mind. But for now, let's not discuss about security. Okay, we'll just go complete this one. We'll create it. So coming to the second point, that is basically publishing the pushing the code Docker image to the container registry, that is Azure Container Registry. We need to have certain prerequisites like if you see here, carefully remember here, where is that? Yeah, here. Push now. Second option is there basically pushing to Azure Container Registry. This is what we are going to do now. You can go through all the step I have defined and everything. One thing we need to remember here is create, as I mentioned, we have accounts. We have to create a container registry in Azure portal. Everything is given step by step. You have to create it. Now this is what we are going to create it, right? So maybe it will take some time. Yeah, it is got created. Okay. Now this Azure Container Registry got created. Then what is the next now? Let maybe make me move here. This better, buddy. Okay. Now what is the next now? Once you log in here, log in to Azure Container Registry, open your terminals and run the following commands or replace your container terminal here. So before that, what we need to understand, you have to remember here, please note, enable Azure pool or this thing. That means you have to give permissions for particular user, Azure pool and a post, you need to give permissions. In my case, pool is not required. Post is something because I want to post the images to the Azure Container Registry, right? Because this is public, private. So what I can do is I can simply give a permission. I can go to the RBAC role. There is a M role. There is a create, give permissions, assign permissions in your Azure level. Then now you can show in an option, right? In my case, I don't want to pull it. I just want to push the changes. Changes in the sense Docker image. So I can give permission for this one. Now, if I give these permissions, question is who need to give the access to. So I will select to myself because I'm the person, right, who's trying to this thing. So I can select my name. Normally, they will not use the individual user. They will use maybe service connections or other permission they'll give, or group setup group they will give, not the individual user. Okay, but for sake of our practice, we can, for now we are defining particular user itself. Okay, let's give the access. Okay, now you are good with the you given the access for the pushing the changes to the Azure. Second thing, there is an option. If you come down for under settings or something, let me check. Yeah, under settings, click here. If you want to give the admin access everything, there is a they have to access it, right? You just tick this one, admin user, under access, under settings, right? Click here. As you click setting, it will get activated. User admin user activated. Now, why we want this one? If you see here, we need to define that. This is a login name. This is a container name. This is the username. This is a password. Now, why we record this one? We will see this one. Now we are good with this one. We given this access also. Second thing is same way as I told you, we have to give a permission. This thing. But before that, I need to log in. Where I need to log in? I need to log in to my Azure Container Registry. Okay. So before that, Azure Container Registry, I will click here. If you have not logged in already, you can type maybe as a login also. If you have not logged in yearly, you can give as a login. Now you can type the username or whatever name you have it. In my case, I can select this one. So I don't want to do any changes, enter. Now if I type as a account list, basically I want to list it. Now I can see I have logged in to my Azure, basically not Azure, my subscription. Now I need to log in. Once I log into the subscription, having the access to the subscription, now I need to basically login to my Azure. So what I need to give is Azure as Docker login Azure. Carefully see registry login server. It is not the Azure name. It is a registry login server name. Login server name is different. If you see here, this is the registry name. This is the login server. This is what I'm saying it. You have to give this name. If you don't know, you can come back. Otherwise, here also, let's say click here on your overview. You can see here login server. This is the ID you needed. That means first will be your ID. I mean your Azure name, whatever Azure name is there. At last, it will dot Azure cr.io. This is the full name. Copy this one. Better I can go here because I need to get a password also, right? I can directly go here because I can copy this login this thing. That means according to the document step, I need to copy as a Docker login, right? So same thing, I use a Docker login. Then I can copy paste it. That's it. Now, once I copy paste it, what happens? Let's see. It is asking the username. This username is what username I need to define is something that you need to know. Username, if you remember here, this is the username, right? It's nothing but same as this, whatever name is given, copy the same name. Don't check this one. Just whatever name is there, carefully copy whatever name is there. Okay. I copy this one. Username is done. What is the password? I can copy the password also. I don't want to show the password. Maybe once time I can show, I can delete it again. Okay, I can hide. Now I can enter it. Okay, now you have logged in to your Azure, particular Azure. That means you have access now. What is the next now? Next thing, we have once you have access to the container, now we have to map the tag now, just like here. If you remember here, tag your image for pushing. After building your Docker image, tag it with the login server of your Azure Container Registry. So as I mentioned, to log in can be found. This if you want to follow, you can check down, but I don't need for now. Okay, if you want to see the Azure name also, we can check that also, but as I mentioned, we don't need that. So we have already logged in, so we have to tag it. While tagging it again, just like before, this time we have to tag with the Azure, not the Docker Hub. Okay, now same just like before, Docker Hub, an image name, and login whatever login server name. Okay, then the image name, tag name. That means just like before, same as it is before only. So let's do that. Now Docker tag, what is the image I want to post? Before that, let me clear the screen. Okay, now let me type first Docker images because I want to list it first. Same thing as I mentioned, I'm going to post this one, same image. Okay, same image, I want to post it. Now let me do one thing. This time let me post this one second time. I mean latest one. Let me copy this name. Can somebody tell me in the comments? It is Docker tag. Then Docker tag, name of the tag, sorry, image, then colon. Now what is the tag name? In my case, this one I want, right? This is the latest, right? Copy, or you can type it according to your convenience. Now next, what I need is I need to define the server login details. That means server details means now, sorry, my bad. Now, if you see here, Azure's login server, they're not asking the Azure name, right? They're asking login server name. Login server means just like before, same thing, login server. This is what we want. So copy this one. Okay. You have to give space. Don't give together. You should give a space. Now done. You have given space slash. Where you want to post it now? As I mentioned, in your case, you give a name, whatever name you have it. Sorry, name you want. In my case, this is the name, right? As I mentioned, you can change name, any name that you wish to give. So maybe let's take the same name because for our better understanding, I'll give a same name, then colon, whatever tag name I want to define. In my case, it is given as a latest. If you want latest, you can define. Otherwise, you can give any tag. Anything that is in your remote side, you can give any name, but anything within your local, this is our defining the local, right? This one need to be defined according to whatever been defined. Hope this is clear. Now I can type here Docker. I can give, okay, I give the same thing, latest, then push. Now, if I type, it is what happened. It tagged it with a proper container name, right? It is tagged in. Now, if I type a Docker images, now you can see this name, right? Docker Pulse, Azure Pulse, this one. So this is the latest. Now you can see, right? We have done it now. So now, how can we push this one? In order to push, as I mentioned, this is basically this one, right? V1. So now I copy this one. Full. Same thing, Docker push. Because access is granted, as I mentioned, carefully check this one. Now, as you push the changes, now you can see how the changes getting pushed. So if you see here, there are so many things, layers, it's getting pushed one by one. Now you can basically see here, that's so bad. Meanwhile, before that, let me show you. If you go to the here under your Azure or Azure Container Registry, you go to the repository, right? Type repository. There is a option under services. Click on repository. There you will see option. Right now it's not there. Let's wait. It's still pushing, right? Let's wait for maybe a minute. So as you can see here, they're trying to push everything. So it may take some at least a minute or something. Let's wait. Okay. Yeah, Tim. If you have any questions, you can raise your questions also. Meanwhile, right? Let's complete this also. Okay, let's complete. Meanwhile, I'll try to show something if possible. Let's see. Yeah. So what we do once it is pushed, once we push the things, now you're good. That means your image can be possible that you can see in your Azure Container Registry as well. Okay, that means you're good. Now you understood how to manage, how to create a Docker image, how to manage them, how to push them to the respective repository that you understood, and what are the prerequisites as well, right? So yeah, maybe let's see. It is still taking, maybe, yeah, it depends on the size of the Docker image and also network. So yeah. Okay, still it is not came. Maybe let me just refresh once. Okay, great. Now you can see the latest because whatever number is there. Now you can see the size of this mask. It is successfully posted, right? Now let us see. This is already post as we can see here. But let us confirm in our portal how we can check that one. As I mentioned, you have to go to the particular content registry or Azure content registry. There inside there you can simply type repository or repo. You just type repo automatically. As you type repo, it will come option for your to source. That is your repositories. Click there. You can see, right? Now you can see the name as whatever. This is the Docker image. This can be now used across your input. Now let's say I want to use this one to the Kubernetes or say the Azure Web App or any other platform, wherever you want. This is ready code. Your application is ready. You just need to install wherever you want to. You need to run the Docker containers and install in the Docker containers inside the containers. Okay. Now, as I mentioned, now there is a tag. If you see a tag name, now you can see when it is got push. Now you can see the number also. If you check the number, the guess number, um, yeah. You can see last number is 686. Now same thing is what? It is also showing a 686, right? Last number. So it is successfully pushed. Now you can see now, as I told you, now the code is ready. Now if you want to use this one to any of the environment, you can use this. There is something called as a container instance. Let's say I want to say this is additional, I'm saying it, but I want to make sure that you understand. Yeah, let me create. What is a container instance? Also, this is another tool, basic service here. Use container instance to create. Let me expand this one later. Right. Use container instance to create and manage Docker containers in Azure without having to set up virtual machines or manage additional infrastructure to get started. Create a container in your container instance. Basically, this is basically a platform where you can run your containerized applications. So in our case, as I mentioned, we have a Docker image ready. Let us deploy here also and see the how we can access it. As I mentioned, I can give any name. I can give maybe same name, container uh, instance 01. Now, if you see here, there is other registry because our image is stored in our this thing, right? We have an image. If you remember, image this is the name, the content name we have it. So this is why you can select it here. If you have a different repository, you can select. So I am selecting image source. They will deploy. They'll take the code from the Azure Container Registry from this particular registry, and they will deploy. This is the name. This is the latest code, right? You can have. I have only the image one image in this particular repository, so I could see this one. I will not think much about the other configuration because, as I told you, for now nothing to explain much. But let's go with the default tag also. Okay, X all I will keep it as default. Let's not do much. So basically, this is one way of basically testing your applications. If you want to just see the application whether it is working or not, after publishing the or pushing the code to the remote, not code basically Docker image to the repository, you can make use of this container instance also. Maybe it will take a minute or something. Let's wait. Okay. Now, if you see here, here, let me just expand this as well. Oh, I cannot expand it. Okay, anyway, so now if your container instance deployment is happening, it is done. Now this workspace deployment for this also is done. Now still it is some other resource getting created. Let's wait maybe. Sorry, I think it's still progress. Yeah, good. Right now, what happened best? What we are doing is this. If you see a container instance, we are using it. Please be aware the Docker Hub has recent introduce a pull rate limit. Okay, let's that is some given some advisor. So okay, for us not record. Let's see. Now we have created a container instance, and we have link with my container registry, basically whatever image we have, right? So now if you see here, why is coming the again? Now you can see one container account one. You can see right now if you want to how to access them. Let's see. The URL is not coming. Maybe it's taking time. Mm, mm, mm. Yeah, let me take this IP. There should be one IP actually, separate this thing. It's not maybe access not granted. Anyway, so I will show you that later. Okay. So basically, we can deploy here also. Through there, we can access the this thing also, like your applications, whether it's successfully done. Okay. So I think maybe it's taking some time as well. That is the reason why you're not coming. Hmm. Colon, I can try VT. Yeah, it is, you can see, right? So it is given the wrong port actually. So you can see right now, it is hello world with whatever name we given. This is a name we given, right? So it is able to access it. So that means now you're confident now. Your application that you push to the remote, that is your Azure Container Registry, also tested well. That means it is confirmed that you have tested the application also in your portal also using the container registry, sorry, container instance. So this is one way of doing it. Now, as I mentioned, users need ID. Okay, let me show you one second. Let me copy the ID. Then copy, remove the ID. Colon you use a particular port number, that is a nginx whatever they listen, right? Nginx listens on port 80. So just give the port on that. Okay, that's how we can define it. So this is a just simple application, right? So Docker image basically, but in your case, the concept remains same, but then the context of the applications or maybe requirement would be different, right? Yeah, I think we are good here because we have now understood how to make use of container instance as well as how to use this SCR, and as I mentioned, we show the image also. So we are good here actually. Yeah. So yeah, we have understood everything. Yeah. Thank you, Tim, once again for joining us. We will connect maybe next week. Have a nice weekend.